Course 3, Lesson 35, we are looking at similar and congruent polygons. So being able to look at the corresponding parts, find missing sides, determine if things are similar, all of those great things. So congruent figures have three things that we need, okay? They need to have the same size, the same shape, and we need the same angles. Now, similar figures aren't congruent when we don't have the same size. We still need the same angles, we need the same shape, and we need to have a proportional side length, okay? So a ratio between side lengths. That means that if we have these similar figures, maybe this one is half of what that one, so we would multiply by 1/2. Or maybe this is a third of what the original one was. Okay, so we have a ratio between all of the side lengths. So in this diagram, triangle EFG is similar to OPQ. So congruent angles must be in the same position. So let's look at this, and all we know is that they're similar. We don't really know anything about the side lengths, but we do know things about the angles. And we can say if angle FEG is 110, since it corresponds to angle POQ, that means that that also has to be 110. These are congruent when we have similar triangles. Okay, so if ABC is similar to DEF, then what is the angle measure of Y? Well, we can say, okay, if angle CAB is similar, or in this case congruent because we have similar triangles, then the angles are congruent to angle FDE, then we would say this would be 65, which means that we now have enough information to find that Y is 25 degrees because the triangle adds up to 180 degrees. All right, so similar idea, if angle R is 45, then angle K is 45, which means we have a total of 110 so far in this triangle. So taking that away from 180 means that we have 70 left for Y, 70 degrees left for Y, which means that T is also 70 degrees. Okay, name the congruent figures. Now, we see that we have congruent figures because we have angles that are the same and side lengths that are the same. These tick marks tell me that that side is the same as this. These two tell me that these two are the same, and the shared side is the same. Now we have to go in order to say triangle. Let's start with one angle, then two, then three. So angle NLK is congruent to, well, if we started with N, that corresponds to L, and then we went to our L, which corresponds to our N here, and then M with our 3. Okay, so we have to go in order. So we would name this triangle NLK is congruent to triangle LMN. Now this isn't the only way to write it, but this is one way. Here are some others that we can name. I'll just do one of these. So we could say that triangle DEG is congruent to triangle HEF. Okay, so make sure that you are going consistently through the triangles. Okay, and you can try some of these out on your own. Now we have some ways that we can tell if things are similar. Side, side, side similarity is if we have two triangles, they have proportional corresponding side lengths, then the triangles are similar. So based on these triangles below, we could say, okay, the side 12 corresponds to 8, and 15 corresponds to 10, 9 corresponds to 6. So are these the same? Yes, because they all simplify to 3 halves. So these triangles are similar. Other way is angle similarity. And yes, if we have these, they kind of go hand in hand, but they might be easier to find in certain triangles than others. So if the angles of one triangle are congruent to the angles of another triangle, then the triangles are similar and their corresponding side lengths are proportional. So if we have the same angle, so 80, 80, 45, 45, 55, 55, then we have similar triangles and their side lengths will be proportional. Now let's find some missing measurements. Are these congruent or similar? Well, we would say these aren't congruent because they don't have the same side length, so they are similar. And we could say, all right, if we have our right triangle right here, 38 degrees, so this is also 38, which means that we have, we need to add up to 90 degrees right here, so we would say that y is 52. Now to find our side length that we are missing, we could set up a proportion, and we could say x compared to 4 is the same as 12 compared to 3. Now there's lots of ways to see this, okay? One is we could simplify this to 4 over 1. You could have cross multiplied, and we can say, okay, if I want a similar or the same fraction, an equivalent fraction, x has to be 16. But we could also figure out that the scale factor between these two is times 4. So we need to do 4 times 4, which gives us 16. Okay, let's try it again. All right, if this angle measure corresponds, and that's 76, then we would say the measure of angle y needs to add up to 90. So we say that that's 14 degrees. And then we can set up a proportion to say x is to 14, so 12 is to 20. We can simplify to 6 and 10, 3, 5, and we can cross multiply and say that we have 5x is equal to, let's see, 14 times 3, 42. Which means when I divide by 5 to find my x, I am going to get 8.4. 8.4 is going to be that side length using my ratio. Okay. So we can use this for a ton of different examples. So if we have a scale drawing, 1 inch represents 4 feet. So what's the scale factor in the building? We would multiply by 4, knowing that we would have to convert units as well. And what's the length and width of a room that's 5 inches by 4 inches? Well, we multiply each of those by 4, and we would get 20 feet by 16 feet. And what's the area of the kitchen? Well, we would do 20 times 16, which would give us 320 feet squared. Okay. Lots of different examples here. You can do some of these on your own. All right, know how to look at corresponding angles, decide if these are similar. Okay, maybe they have a scale factor between them, maybe they don't. Okay, so check that. All right, also check those proportions. All right, well, I hope this is helpful for your homework and for studying.